Huh. What is nomenclature and what does it mean in organic chemistry, especially? Actually, previously, the name were given according to the trivial system that sometime scientists give the name of the compound from their source, for example, urea, because it was obtained from the urine, acetic acid, as it was obtained from the acetum, that means vinegar, and butyric acid from butyrum. So the sources of compounds were like this, and one of the compound that is a tranquilizer, barbituric acid. The scientist who discovered barbituric acid, uh, her girlfriend was Barbie. So due to her name Barbie, he named it barbituric acid because it was acidic in nature. So it is very difficult to memorize the name of the organic compounds, especially from these trivial names. So they have developed nomenclature by a union that is named International Union of Pure and Applied Chemistry. So what are the basic things regarding nomenclature? As I told you that there are millions of organic compounds containing carbon as an essential element. So remembering the name of each compound is not possible. Therefore, a system of nomenclature has been devised to name these compounds. Two commonly used two commonly used systems of nomenclature are common names that are called trivial names as well. The old and the ambiguous way of naming. Ambiguous because I have told you that it is difficult to memorize all the names and the correct formula of the compounds. And another one is the systematic name, that is the I.U.P.A.C name. I.U.P.A.C stands for International Union of Pure and Applied Chemistry. And there are certain changes in the rules time to time as the chemists face some problems. So as you remember that in isomerism, I taught you about cis and trans isomerism. So when the scientists are aware of the geometrical isomerism, so they introduce the term cis and trans as well, that you will see again in the nomenclature. So this method of nomenclature was used before. This is about trivial system in 1892. Before 1892, in the system of nomenclature, the compounds were named based on their history, such as source of the origin, as I have already told you, or simply on the name of the whim of discoverer, sorry, whoever discovered, and according to his desire, he can name the compound. And in present era, Dr. Salimuzzaman Siddiqui in Pakistan, HEJ, he was the brother of Chaudhry Khaliquzzama, who was the leader in Pakistan movement. So, according he discovered a compound from the Vincarizia plant, and he named the compound according to the Indian Hakim. Hakim means the doctor in Unani medicine. So the name he discovered, the compound that he discovered, he named it Ajmalin. Ajmalin, in the name of the Hakim Ajmal. So this is on the whim of the discoverer. So urea from urine, morphine from the word morphus because it was an analgesic and it relieves the pain. So Morpheus was the Greek gods of the dreams. So the name of compound was morphine. And barbituric acid, I have told you about. The Barbara was the name of the uh, friend of the scientist who discovered the barbituric acid. But uh, uh, some common names exist before organic chemistry and became the organized branch of the chemical science. So these names are still prevailing in modern system as well. For example, methane, the word meth is obtained from the marsh because methane was obtained from the marshy places. And ethane, propane, and butane. These were the trivial names, and we still include these names in our systematic nomenclature, I.U.P.A.C nomenclature. Isobutane and pentane, these are still the part of our syllabus. Not in A-level syllabus, but it is in chemistry, and uh, systematic name also includes sometimes this term iso, neo, and these terminologies. Neopentane, where all the groups are different. But in A level, these are not included. A means A2 or S level, both. These are not included in A2 and S level, but it is included in um, other systems prevailing in the world, India, Pakistan, and other countries, because common names are also important, and these names are uh, frequently used in different products. So it is important to include these names in the syllabus, but in at Excel and CIE A level, these are not included. So you don't bother to memorize these terms. Okay. Now the I.U.P.A.C system was the Geneva system initially, and at that time, International Union of Pure and Applied Chemistry was not there, but the International Chemical Congress was there at Geneva, and they developed the naming system. Later, the International Union of Chemistry, not the Pure and Applied Chemistry, then the name of the institute and the organization has been changed, and International Union of Pure Chemistry at Liege, Belgium was developed, and then it is then converted into I.U.P.A.C system of the nomenclature in 1930. But this history is not in our syllabus. We don't bother to memorize these things. Then it was modified in 1958. Okay. Some new recommendations were there because, as I told you, that as the scientists feel some problems, so they need to introduce some new rules, some new recommendations. Then another was published in 1993, and after that, the most recent one that I know, it was the recommendation in 2013. But the syllabus that we are covering, it is already following the 2013 rules. Okay. Now, now the compound, as we have seen in previous classes, that butane can be the name of the different compounds. They have different structures and different isomers are there. But if we are writing the correct I.U.P.A.C name according to name of the organic compound according to the I.U.P.A.C rules, and we follow the recommendation, all the recommendation, including 2013, then there would be one name for one compound. Okay. So remember that I.U.P.A.C rules often offer several different ways to name a single compound. Okay. So one compound, one name. But even today, when you will study in A2 level, that some of the organic compounds have two systematic names. Okay. So sometimes we have two or several names. Thus, although it is true that no two compounds can have the same name, okay, it is incorrect to believe that there is only a single I.U.P.A.C name for a particular compound. So a single compound can have two I.U.P.A.C names. For example, It is not the part of your A syllabus, it is the part of A2 syllabus, that if the compound is this, the name of this compound is paracrisol. It is also recommended by I.U.P.A.C, and its name is also 4-methylphenol. So both are the I.U.P.A.C names. I.U.P.A.C recommend both the names for this compound, but it is not the part of your AS syllabus. Now, what are the principles, rules for I.U.P.A.C names? Systematic names can be divided into two parts. One part describes the hydrocarbon chain or the framework of the carbon atoms. And one describes the attached group or the functional groups within the hydrocarbon chain or the carbon framework that we have seen in our some of the previous classes. And one indicate where the functional groups are attached, means you have to mention the position of the double bond, position of the OH, position of the chlorine, or any other functional group. Now, rules for open chain compounds. Open chain compounds means which have the free ends, for example, alkane, alkene, alkynes. So according to the I.U.P.A.C nomenclature, the name of an organic compound consists of the following three parts. One is called the word root, and another is the suffix and the prefix. Suffixes at the end. Word root is the basic name, and prefixes are the initial part of the name. And in our syllabus, we don't remember what is root, what is suffix, what is prefix, but for it is important to understand that how to write the name of the organic compound. Now see, this is the simple framework structure formula of a compound which contain 1, 2, 3, 4, 5, 6, 7, and 8 carbon atoms. So it is a framework of 8 carbon atoms. There is no functional group. If there is no functional group, then the two parts is that first you find the parent chain or the basic chain, and then find the attached group to the compound. Now we can number the chain to find the locands. These are the groups which are attached to the basic chain. So the name of this compound is 3-ethyl, 2-methyl, 5 carbons, so pent, and all the carbon-carbon bonds are single. So that's why we write pentane. Ethyl group is on the third position, but we have written it first because ethyl starts with E and methyl starts with M. In alphabetic order, E comes first and M later. So we always follow the alphabetic order for the prefixes. These are the prefixes. These all are prefix. This is the word root, and this is the suffix right now for this alkane. Suffix for all the alkanes, alkane is ANE. So this is the word root. What is word root? Word root represent the number of carbon atoms in the basic chain or the parent chain. Okay.
Yes.
This is the suffix I have already told you, and suffix is added to the word root at the end of the compound to indicate which class of organic compound is this. So it also explains that whether it is a simple alkane or having double or triple bond or any other functional group. According to the functional group or double and triple bond, it changes that you will see in later slides. And these are the prefixes. And these are the locants. Locant describe the position. So indicate the position of the groups which are attached to the parent chain or the word root. Okay. I will send these slides. Okay. Don't worry. Now, see, in previous case, we have chosen this as a basic chain or the parent chain. And here it is almost same, but parent chain contain a double bond. In previous slide, we have started the numbering from here, but here we will start the numbering from here. Why? Because we prefer the functional group from where they are nearer. This ethyl and methyl are not the functional groups, but this is the functional group. So whenever functional group is there in the parent in the compound, then we prefer that the number should be least for the carbon atoms which are having any functional group. So now see, this is the basic chain. These are the side groups. So the numbering starts from here, as I have told you. And the name of this compound, we write prefix first. So 3-ethyl, 4-methyl, pent, 1-ene, because the numbering of the position is very important. Because in means that we have studied during homologous series that in means at least there is a double bond between any two carbon atoms. So the position of the double bond is very important. So we write it pent 1-ene. So again, you can see that this is the word root. This is the suffix. These are the prefixes. And these are the locants. These all are locants. And what are locants? You have seen in previous slide that they indicate the location of the group or the functional group on basic chain or the parent chain. Okay. Now we have seen the word root, parent chain. Now this is very important. What is the parent chain? See, number one, we prefer that it should be the longest chain. It should be continuous. Continuous chain of the carbon atoms and including all the functional groups. So this is very important point. One, it should be continuous. Two, and possibly all the functional groups should be there. And all the groups. And multiple bonds are also functional group. Remember that. Now, come to previous slides. Now see, here, in this compound, what if we select this compound as a parent chain? See, CH2, CH3, it should be CH. It is typographical error. CH, CH2, CH3, CH, CH3, and CH3. Now think about this. What if we select a different parent chain? Suppose if I have selected this one as a parent chain, so this whole is considered as a group. So only one group is there. Although the compound parent length of the parent chain is same 1, 2, 3, 4, 5. So as we told that it should be the longest chain, so it is the longest, no problem. But it includes only one group. But when we select this straight chain as a parent chain, then there are two groups. So we should consider this as well, that there should be all the possible groups and the functional groups. So it is better to select a chain which has maximum groups and the chain should be the longest accordingly. लाजमी नहीं है, not necessary that it is always long. Sometime we select the short chain as compared to the longest one. I will show you this. Okay. Now again, come to this point. Sorry. Come to this point. Now see, I am writing one more compound here. CH2. It is CH double bond CH2. CH2, CH3, CH3, CH, and leave it. Leave it here. This is CH2. Okay. So if we see that it should be the longest. So the longest chain should be 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. So the longest chain could be it is the longest chain. But if you are selecting this as a longest chain, then it is wrong. This longest chain is wrong. Why? Because the functional group or the multiple bonds are outside the longest chain. See, so it is not only necessary that it should be the longest, but it should be continuous, as well as the all the functional groups and the multiple bonds must be included in the basic chain. But now you can see that multiple bond is outside. So this is wrong. So what should we do? This is not the basic chain. We try to select another one. If we select this as a basic chain, then what happened? 1, 2, 3, 4, 5, and previously 1, 2, 3, 4, 5. They have the same number of carbon atoms, but we have selected this because all the multiple bonds or the functional groups are there. So these are considered as groups. And numbering, where should we start the numbering? Both the double bonds are on the same position. If you start from here, 1, 2, 3, 4, 5. So the position of double bond is 1 and 4. And if we see the position of methyl, then methyl is at position 2 and ethyl is at position 3. But what if we consider the other way of numbering? 1, 2, 3, 4, 5. Now, in this way, you can see that the position of double bond is still 1 and 4. So 1 and 4 for ene means for double bond, and ethyl is on third position, and methyl is on fourth position. So if we consider that, what should be the correct way of numbering? So until this condition, it is same, but for methyl it is different. So if functional groups does not decide the start of the numbering, that from where you should start the numbering, then what we do? Then we consider the other groups. So methyl is nearer from there, so we consider this numbering. Okay, this numbering is correct. So this should be 1, 2, 3, 4, 5. So now see what should be the name of this compound. We first write the prefix. So prefix is methyl and ethyl. Ethyl start with E, methyl start with M. So the name of the compound should be 3-ethyl 2-methyl and there are 5 carbon atoms. So now we write the basic name of the parent chain. Pent. But there is 2 double bonds. We will see in later slide as well, this type of nomenclature. We add a vowel, a, penta. Then we write the position of these double bonds. It is in between 1 and 2, so we consider 1, and 4 and 5, so it is considered 4. 1, 4 diene. Di because there are 2 double bonds. So wherever there is a doubling, then we should use the matrix prefixes di, tri, etc. Okay. Now, so here I have told you this because of the just for explaining that parent chain should not only be the longest, but it also include all the functional groups and the multiple bonds. But why we are writing here penta 1,4-diene or etc., we will see in later slides. Now, these are the prefixes. Initially, these prefixes up to butane have been obtained from the trivial system that meth. Now it is considered as meth means 1. But actually, it was the correct origin of the name was of methane was that it was obtained from the marshy places. So for 1, if there is 1 carbon atom in the group or the basic chain, then it is called methane. 2, so ethane or ethine. 3, then propane, propine. If there are 4, then butane or butine, butyl group. So but means 4 carbon atoms. Now, if the chain comprises 5 or more, then we use the matrix prefixes, that is pent. So the Greek numerals are used. Pent means 5. Pent, this is the general word in English. Pentagon, hexagon, because it has 6 sides. Hept, 7. Oct, 9. Oh, sorry, oct, 8. and 9 means non, and 10 means dec. So hept, oct, non, and dec. In S level, nomenclature is up to 10 carbon atoms, but I will show some more because it can be there. Okay, but not it is not important to memorize these terminologies except the up to 10. Okay, after 10 you do not need to memorize. Now an extra a is added to the word root if the suffix to be added to the word root begins with a consonant. As we have seen in our previous slide, you can see here I've used the word diene. So this is the consonant. As it was the consonant, so we have added a here to avoid two continuous consonant. Okay, so this was added. So similarly, you will see some more example in next class, next slides. Now say 11 for undec, 12 for dudec, 13 for tridec, 14 for tetradec, 15 for pentadec, 16 for hexadec. Similarly, heptadec, octadec, nonadec, and the 20th is icosan. There is a different term. You have learned in biology icosahedral for the structure of virus. The bacteriophage virus has icosahedral head. So icosa, sometime it is written without e. So icosahedral means sides. Icosa means 20. So icosahedral virus has a head with 20 sides in its head. And after that, it is hanicosan and docosan. Yeah, docos. But you do not need to memorize this slide. This is not the part of our A level. Now the primary suffix. We have already mentioned that what is meant by the primary suffix. Suffix the ending name, and the ending name for alkane, alkene, and alkyne, we have seen that. For alkane, it is N. For alkene, which are unsaturated, that we have discussed in our previous class, that double bond, then ene. And for triple bond, if two double bonds are there, then this is diene. If there are three, then there would be triene. If there is a triple bond, for triple bond, the suffix is ion. If there are two double bond, then this is diion. If there are three, then it is called triion. So what is primary suffix? Primary suffix is added to the word root at the end of the word root to indicate whether the parent chain is saturated or unsaturated. If N is there, it means it is saturated. And if ene or ine is there, then these are unsaturated. So you can see here, these are some examples: butane, propene, ethine, butadiene, 1,3-butadiene. But the better name, according to the I.U.P.A.C rules recommended by 2013, so it should be buta 1,3-diene. But in Indian and Pakistani syllabus, 1,3-butadiene is also accepted, but it is not according to the rules of 2013 recommendation. Similarly, here we should write 1,3-butadiene instead. We should write buta 1,3 diene. So you can see here 1, 2, 3, 4. So 1 and 3 position triple bond is there. And similarly here 1, 3 pentadiene. So it should be written according to the recommendation of 2013. Penta 1, 3 diene. Okay. So we add
Okay.
extra A to indicate that there are 2 double bonds or 2 triple bonds to avoid the consonant that we have seen in our previous slide. Now these are very simple organic compound. These all are alkanes. This is the homologous series of alkane. They have a difference of CH2. You can see between the next member, 2 consecutive member. 2 consecutive means in Urdu it is called दो लगातार members के दरमियान. So methane, ethane, and these are the distillate formula and these are the molecular formula. And here the prefixes are there for their respective. So pentane, hexane has 6 carbon atoms, heptane, octane, nonane, decane. Then undecane and dodecane are not the part of our syllabus in A level, but in Indian and Pakistan boards, these are included and for higher chemistry as well. Now, if there is double bond, then ethene, definitely if carbon-carbon double bond is required, so minimum 2 carbons are must be there. So these are the different alkenes. Similarly, different alkynes. Okay. So that's up to this this class, and inshallah in the next class we will see further detail. But I think you should rejoin. We have a little bit time more. Okay.
Okay.